Okay, so now we've already looked at adding and subtracting rational expressions with like denominators. Okay, now we need to look at what it looks like without like denominators or with unlike denominators. Okay, so without like denominators or with unlike denominators. Again, we go back to our basic fraction skills, okay? So if we want to add or subtract fractions, you must have a common denominator. Only adding and subtracting, okay? This is going to be one of the biggest parts of this test. On adding and subtracting, you must have a common denominator. Multiplying and dividing, you do not need a common, okay? Adding and subtracting, you must have a common denominator. Because when you're talking about adding and subtracting, you need your units to be the same. Okay, I can't put half together with a quarter and then just add them and pretend like it's 2/6 or something like that, okay? If you think about, just as an example, half of a pizza, okay, so that would be your half, and let's say I do a half and a quarter, okay, so this would be 1/2 plus 1/4, okay, together, if I take this little piece, and you imagine there's my half, plus another quarter, I get 3/4. So again, I encourage you, when you find yourself getting stuck when you're looking at your rules, go back to things you know. If I have 50 cents, which is half of a dollar, and I add another quarter, I now have 75 cents, which is 3/4 of a dollar. Okay, go back to money, go back to pizza, go back to pies, whatever makes it easiest. Use your basics to help remember all of the rules. If you know the rules, the rest is kind of easy. The rest is just putting some variables and stuff in it. So, keep that in mind. We have to have a common denominator. So, for instance here, the way we get from 1/2 plus 1/4, it wasn't 2/6. Okay, and we know it's supposed to be 3/4, and we get that by making a common denominator. So this right here would become 2/4 plus 1/4, which gives us the 3/4. Okay, we basically just took this and made it into the proper units. 2 pieces out of the total 4. Okay, keeping your units consistent. That's what we're trying to do here with fractions. So you have to find a common denominator, and we can multiply top and bottom to make these things the same. As long as I multiply top and bottom by the same thing, essentially I'm multiplying it by 1, because 2 divided by 2 is just 1. So if I keep the top and the bottom the same, then I'm not changing the value, just changing the way that it looks, which is what math and algebra is all about, changing the way it looks so that we can solve for things. Okay, so step 1, if I want to add and subtract rational expressions with unlike denominators, is to actually find the common denominator. Okay, we cannot do anything until I have a common denominator. Once I get a common denominator, okay, rewrite each rational expression as an equivalent expression whose denominator is the same found in step 1. Okay, step 3, add or subtract. And we will talk about these steps as we go through an actual example. Okay, so add or subtract numerators and write the sum or difference over the common denominator. Step 4, write the rational expression in the simplest form. So that would be your simplify step. Okay, so find the common denominator. Okay, rewrite each rational expression with the common denominator, add and subtract the numerators, and then simplify. That's what we're looking at doing. So, for instance here, 10x squared and 25x. We have to figure out what is my common denominator, which you're going to see all over this paper as CD. Think about both your x's and your number. So between 10 and 25, what is their common denominator? 50. 10 goes into 50 evenly, 25 goes into 50 evenly. Between x and x squared, what is their common denominator? Okay, this is easy because we did greatest common factor, where we found when we were taking out the greatest common factor, we always go with the lowest exponent, but when we're finding the common denominator, we're going to go with the highest exponent. So this was x squared, so this one needs an x squared. Now, from there, we are going to figure out what do I need to multiply by in order to get 50x squared. Okay, so what would I need to multiply 10x squared by in order to get me to 50x squared? Well, really, I just need the 10 to become a 50. And I do that by multiplying it by 5 over 5, top and bottom. So if I multiplied by 5, I would get 50. So that's what we're looking for. Then you do the same thing with the next one. What do I need to multiply 25x rather, to get to 50x squared? Well, I need a 2 and an x. That would give me 50x squared. So I do the same to the top and the bottom. Okay, once you're here, you go ahead and you just multiply. 3 times 5 is 15. 10x squared times 5 is 50x squared. Okay, and then we're going to add 7 times 2 is 14x over 50x squared. Now I've got common denominators just like I want. I add my numbers together, 15 plus 14x. Okay, don't actually put those numbers together. One has got an x and one does not, over 50x squared. Look for common factors, look to see if it factors, look for GCFs. None of the above here, so that is my answer. If you put the 14x first, that's perfectly fine. It's actually a little more mathematically correct as far as the proper way to write things. You write your x first. So that really would be my answer. 14x plus 15 over 50x squared. Of course, if you write it this way on your test, I'm not going to take any points off. That's fine with me. Okay, so same thing with B. Now B looks a little more tricky, but it's really not. Okay? It looks a little more tricky, but it's really not. So this is kind of hard to tell. But if I factor this, makes it a lot easier. Okay, so we're going to factor this. This is a perfect square. Okay, square root of x squared is x. Square root of 4 is 2. So I get x plus 2 and x minus 2. Oops, forgot to actually write the minus 2. Helps. X minus 2. Okay, here I want these things to match up, so I'm going to take that negative out of the front of the x, and I'm going to make this negative 1, x plus 2. Okay, this part is over the 6x, we still have minus, and this part is over the 3. So now, figuring out what our common denominator is. Once you have your denominator factored out, it's just going to be one of each of them. Okay, I need an x plus 2 in both. I need an x minus 2 in both. And I need a negative 1, which I'm going to go ahead and write in the front there. Can you tell what that is? It's a negative 1. Okay, I have an x plus 2. You just go through your whole list. I only need 1, right? I have an x plus 2. I've only got 1 in each. That's fine. I have an x minus 2, and I have a negative 1. Now, when you go through, you just have to figure out what does each one of them need. I have an x plus 2. I have an x minus 2. This one just needs the negative 1. So 6x, x plus 2, x minus 2. We're going to multiply this by negative 1, top and bottom, minus. Now this one, I've got the negative 1, I've got the x plus 2, it's missing the x minus 2. So we're going to multiply it. Negative 1, x plus 2, times x minus 2, oops. I'll show you why I keep doing that here in just a second. X minus 2, x minus 2. Okay, so here, that's a times. Okay, that's multiply, that's multiply. So I multiply top and bottom by x minus 2. So now I'm going to end up with those common denominators. We have to actually multiply these out on top. 6x times negative 1 is negative 6x. Okay, here, be very careful. This has to distribute. Okay, and it's going to carry. Well, we'll do that part in a second. So we've got this x plus 2, x minus 2, a negative 1 out front. Okay, and then we've got minus 3x minus 6 all over negative 1, x plus 2, x minus 2. Now this last step, we need to actually put them together. remember to distribute that negative. So negative 6x minus 3x is negative 9x. And then I've got negative makes positive 6. Okay, because I'm distributing that negative. Negative 3x, negative 6 makes it positive 6. All over negative x plus 2, x minus 2. Okay, and that would be your final answer. If you wanted to cancel negatives and make this positive negative, that would work also. Okay, those would both be correct answers. So C, same sort of thing. Okay, C is going to be the same sort of idea. I didn't leave myself very much room. I need to learn how to write smaller, apparently, or make more room on these things, right? Okay, so I've got common denominator. This is going to be the big part, is figuring out your common denominator. I've got a 3 and a t in this one. I've got a t plus 1 in this one. Okay, notice I can't just do a plus 1. When we're talking about finding a common denominator, we can only multiply things in. Okay, so I can't just take this t and say plus 1, top and bottom. That does not work. You cannot add 1 in. The only way to make a common denominator is to multiply top and bottom. Okay, multiplying top and bottom. So that's what we have to consider. I've got to be able to multiply. This plus sign, remember, binds those things. Those things work as one. Okay, those things are married. They work as a group. So 3t and t plus 1. That's my common denominator. That's what I need to work on. So this piece here needs a t plus 1 top and bottom. Okay, I am perfectly okay if you write it right here. T plus 1 top and bottom. That's why you kind of see me keep writing it off to the side. Here, I need the 3 and the t. So 3 and the t, top and bottom. So let's go ahead and multiply this out. T plus 1 times 2. Distribute. I get 2t plus 2 over t plus 1, 3t, plus 5 times 3 is 15t over 3t, t plus 1. Doesn't matter which order it's in. The 3t can come first or second. Doesn't matter. Now we need to actually add them. 2t plus 15t is 17t's plus 2. Okay, 17t plus 2 all over 3t times t plus 1. This is going to be another one of those units where the answers don't look like they should be answers, because it looks like you should be able to do more with them, but they really can't. Look for GCS, look for anything that cancels. If there aren't any, don't make it happen. Okay, you just leave them alone. So, let's take a look at this next one. Okay, take a look at this next one. Try to ignore all the other stuff that I got going on up here. Okay, so 3 over 2x squared plus x minus 2x over 6x plus 3. So first thing we need to do is we need to factor these things out. I'm going to go ahead and do it from right here. Okay, here I've got a GCF of x, and I get 2x plus 1 left. Okay, and I'm going to go ahead and cancel out my other little fraction. I've got it actually factored here. I've got a 3 that can come out, and a 2x plus 1 left inside. Okay, 6x plus 3, that's done. So now when I look at my common denominator, I've got an x, I've got a 2x plus 1, and I've got a 3. Okay, a 3, an x, and a 2x plus 1, they're all accounted for. 3x, 2x plus 1. So here, I've got everything but the 3. So top and bottom by 3. Top and bottom by the same number. 3 times 3 is 9 over 3x, 2x plus 1. Notice that I never multiply out the bottom. Okay, I don't need to multiply it out. Once I get to the end part, I want to be able to see if I can simplify. So if I multiply it all out, then I have to turn around and factor it all back out to see if anything simplifies. So save yourself some trouble, and don't worry about doing that. Okay, here I've got a 3, I've got the 2x plus 1. The only thing I'm missing is that x. So I get to multiply top and bottom by another x. So 2x times x gives me 2x squared. And on bottom I now have 3x, 2x plus 1 Now we need to subtract. Okay, now you need to go ahead and subtract. So I get 9 minus 2x squared over 3x, 2x plus 1. Okay, there is nothing else. That is your answer. Nothing else. There are no GCFs. There are no GCFs. There are no common factors, top and bottom. Hold on, my screen froze. Happens at least once a lesson. Because I talk a lot, that just kind of happens. So, E. Okay, E. And let me grab a highlighter here, because kind of getting to where you can't really see what I'm doing here. 1 minus, okay, there's the problem, 1 minus m over m plus 1. Okay, so just like with anything else, if I don't have a denominator, I make one. I just put this thing over 1 and go from there. Okay, I put it over 1 and we go from there. So, I've got an m plus 1. Remember, I can't just add m, we only can multiply. So my common denominator between 1 and m plus 1 is just m plus 1. Which means I need to multiply the 1 over 1 by m plus 1 over m plus 1. Okay, if you think about it, m plus 1 over m plus 1, it's still 1, so we haven't changed any values. So minus m over m plus 1. Okay, this is going to give me m plus 1 over m plus 1 minus m over m plus 1. I now have a common denominator. M minus m, okay, is going to cancel. M minus m, that's going to cancel, and I have 1 left on top, and an m plus 1 on bottom. Okay, so just like with normal fractions, if I don't have a denominator, put a 1 there. Okay, just put a 1 there, that's how that works. F, and we are almost done with this. F, okay, I've got 2x over x squared plus 2x plus 1, so we need to factor. Okay, we need to factor target product, target sum. Target product is 1, target sum is 2. Two numbers that multiply to 1 but add to 2 are 1 and 1. And it is a coefficient of 1 in front of x squared, so I am allowed to do the shortcut. I'm going to rewrite my problem right here. So I've got 2x over the x plus 1 plus, so here I've got an x, and this is a square root. Square root of x squared is x, the square root of 1 is 1. So I get x plus 1, x minus 1. Now here you have to be very careful, because it's going to be a little bit different when you talk about your common denominator. Okay, because typically when we are looking at, say for instance back up here on B, I had an x plus 2 in both, okay, and I had an x minus 2, so my common denominator was just the x plus 2, x minus 2, and that negative 1. Okay, here though, I have an x plus 1 in both, but I also have another x plus 1 in this one. So when you talk about your common denominator, I need to actually have 2 of them, because this particular fraction has 2 of them. So x plus 1, and then an x minus 1. Okay, this has 2 x plus 1s, this has 1, this has an x minus 1 also. So you have to be careful. If both the x plus 1s come in the same, okay, if they both come in the same, and if you prefer to think of this as x plus 1 squared, that's fine. And this would be an x plus 1 squared. Nothing wrong with that. You can do it that way as well. So here, the only thing I need is the x minus 1. So we're going to go ahead and multiply that in. Okay, so I'm going to get 2x times x minus 1 over x plus 1, and we're going to write squared. Okay, that's just the x plus 1, you get the x plus 1 squared, and then our new x minus 1, I multiplied top and bottom, plus, now this one needs another x plus 1. I've got one x plus 1, I've got one x minus 1, so it needs another x plus 1. So x plus 1, top and bottom. So now on the bottom I'll have x plus 1 squared, x minus 1. Okay, now add these things together. You're going to want to go ahead and multiply these in. Okay, it's going to make your life easier. So 2x squared minus 2x plus x squared plus x, that's multiplying this side now, all over x plus 1 squared x minus 1. Okay, x plus 1 squared x minus 1. Combine all your like terms and I get 3x squared minus x over x plus 1 squared x minus 1. Okay, you can take a GCF of x out here, but it's not going to help you. You're going to have 3x minus 1, which is not going to cancel with anything, so you just get 3x squared minus x, and x plus 1 squared and x minus 1. That is your final answer. Again, some of these things are kind of ugly. That's just the way they go. Okay, so here's your chance. Do your 2. Okay, I highly suggest that you actually try to do these. Hit the pause button. Try to work through the 2 problems that you have here. See what you get and see how well you match up with what I've got. Okay? Alright, so here we go with these. Your turns. Okay, looking first at my common denominator. I've got an x and a 2x squared, so I still need a 2 and an x squared, looking at the greatest exponent, right? Looking at the greatest exponent now. GCF, we look at the smallest exponent. Common denominator, we look at the greatest one. So, 2x squared. So on this first one, I need a 2 and another x. Top and bottom. 2 and another x, top and bottom. Here, I need nothing. I already have a 2x squared. If I don't need anything, don't put anything. Okay, so here I get 6x over 2x squared plus 5 over 2x squared. Add those together, I get 6x plus 5. Do not put them together. They are not like terms. It's like oil and water. Can't put them together. 6x plus 5 over 2x squared. That would be your answer. No GCFs, nothing factors, nothing cancels. That's just your answer. Now, B. A little bit more going on in B, but not too bad. Okay, we're going to target product, target sum. Target product is 6. Target sum is -5, so my 2 numbers are going to be -6. Oh, just kidding. How about -2 and -3? Those would multiply. Multiply to +6, add to -5. It is a coefficient of 1 out front, so we can shortcut. So I've got 5 over x minus 2, x minus 3, minus 5 over x minus 3. Okay, common denominator. Hopefully it's pretty obvious here. We got a common denominator of x minus 2 and x minus 3. Okay, x minus 2 and x minus 3, so this one just needs that x minus 2, and we will go ahead and multiply that in. Just for things to be proper, I'm going to throw my parentheses around my x minus 3. Okay, we're going to distribute up here. 5, this is going to give me x minus 2, x minus 3, minus 5x minus 10 over x minus 2, x minus 3. Put those together. Remember to carry that sign. Okay, this is going to be a negative and a positive. Change those signs. Distribute that negative. Becomes a negative and a positive, so I get -5x plus 15 all over x minus 2, x minus 3. Okay, all over x minus 2, x minus 3. Don't stop there. You have to check for GCFs, and I have one. Look up here on top. I can take a -5 out, and that leaves me with x minus 3 over x minus 2, x minus 3, which means those x minus 3's need to cancel. Final answer. This line is absolutely restricting my mathematicalness. X, that's totally a word too, by the way. -5 over x minus 2. Final answer. -5 over x minus 2. Okay, that would be the final answer. So, that is adding and subtracting rational expressions with unlike denominators. Okay, probably the harder part of all of this stuff, but hopefully it isn't too bad. Biggest part again is making sure you can factor and then figuring out what that common denominator is. Okay, have a good time.